Hello guys, it's RoboDairy and I'm back with my 6th video, and today I'm going to be talking about actuators. So in this video I'll be explaining what actuators are and how they can affect the outcome of the robot's movements. So let's just review what an actuator is first. So actuators are the main components that allow the robot to move. They are hardware and are typically in the form of a motor, as shown as the right, like this not this VexIQ, FTC Rev Robotics motor. We can see that it looks like it can probably move and rotates, probably a different mechanism. So the motor can be powered by any type of power provider, such as electric, solar, hydro, and much more. But on this Rev Robotics motor, it's being powered by electrical energy, converting to mechanical energy. So I'll talk about that in a bit. So why do we actually need actuators and motors is because motors help provide the movement for the entire robot. They can help with rotating, lowering, twisting, or pretty much anything that requires any sort of movement. If actuators are not on your robot, then it wouldn't move at all. Actuators can also represent the movement of internal components. So that's important to consider too, but you probably do need actuators, especially when building a robot that has to move around. Actuators are definitely important. So what do motors mainly consist of? Well, motors mainly consist of 6 main parts. So number 1 is the rotor, the part that rotates. So we can see over here this rotor. It's the part that rotates. Then we have the stator over here, stator, which helps to the part that using the force to rotate the rotor. So that's the one that mainly converts the electrical energy into mechanical energy. Then the bearing, which helps support the rotor over here and over here. And then the bracket, which holds together the motor. You see down here, this is really important and crucial. And then the shaft where you can put your end effectors. So it's the output shaft, and that's basically where all this mechanical energy is being provided and put to. So we can also see this with the previous slide, 2 slides ago, that we can already see our shaft in the top of the corner. You can also see where the wires lead to. Oh, and I forgot to talk about the last one, the wire, which connects to the power supply. It's important to consider the wire too, otherwise the motor wouldn't even work. So here we can connect the wire over here. And then we also have our bracket overlaying the whole thing. And we can also consider this whole section of bracket. On the inside, you'll see mainly the components. Then here's the output shaft, just to kind of give you real experience of the motor. So now let's talk about how the energy is converted. So electrical motors must convert electrical energy to mechanical energy, obviously. So they do this by taking in the battery power from the brain through the wires, and then using the stator, they convert this electricity into mechanical energy. So they basically take in the electrical energy from the brain, imagine the brain's here, then you just take it in from the microprocessor brain, it goes through the lead wires, and then it goes to the stator. Using the stators, it converts this energy from electricity to mechanical energy, and then the rotor starts to rotate. Up here, this rotor, it starts to rotate up here, this part, and then that part eventually rotates the output shaft. So we have all these complex parts working together. Then of course we also have other parts like the bracket, and you mainly need these. So you can also have extra parts like the winding and all that stuff. And then after the shaft rotates, you basically can move your mechanism. So how is it used in school robotics? Well, actuators are used in school robotics all the time. Actuators are needed to keep the robot moving. They are connected to a main brain of the robot, which gives actions on what to do. For example, this VexIQ motor, shown to the left, over here, has a wire slot over here, connecting it to the brain. This allows the user to program certain actions for the motor. So the electrical energy goes through. This might look a little weirder than the FTC motor, but all the motors come in different shapes and sizes. And also, one thing to say is that based off the motor, you want to put certain, for example, you want to put motors based off how much they weigh, how much voltage they put through. For example, in FTC, what they do is they have they have all sorts of motors, but I'll talk about two of them. One of them is the HDX motor and one of them is the rev motor. The one that you saw before was probably the HDX motor. And basically, the HDX motor weighs more, but it outputs more voltage. So you probably need to use an HDX motor for something like moving the drive base around, and then you can use the other rev motor, which is lighter and transmit less voltage and mechanical energy through. You can use that one for smaller mechanisms like a claw, maybe even the lift sometimes. So here I'm showing you guys a video on like how, so just ignore the caption that will come up, but basically this VexIQ robot is moving and turning, and it's basically like school robotics. It's turning around using motors. So where are the motors exactly? The motors are around here, around here, around here, and around here. That would be the ideal, what you might think. But also you can use gears, as you can see gears. So they probably just use one motor here, or one motor under, and then they use gears. So you see this gear rotates this, then another gear is an idle gear, and then it rotates this one. Same thing on this side. So that way both the drive base moves the same direction at the same time. So then this is a simple wheel drive base, nothing special, not an omni wheel. And then of course you have your wires connecting the motor to the brain. And this is by the Vex Robotics YouTube channel. So let's watch that again. Yep, turns. So yeah, that's the actuators are doing all that work with the turning, but you also need to program them. So a robot's effectiveness, as we talked before, is based off whether your robot is successful or not. And basically, just like the sensors are 25% of the robot's effectiveness on the field, actuators are 25% of the robot's success too. So thank you for watching this video, and remember to follow me on Instagram, like and subscribe. And if you have any questions on my video, just ask them in the comments. Thank you.